I would like to introduce our speakers. We will have Rosanna Harding and Matthew Ostro, Hunter Ruthrath, and Glenn Taybolt. Glenn, thank you for being here. I will turn it over to you.
Thank you, Tennille. As she said, my name is Glenn Taybolt. I'm CEO and co-founder of STS Steel. We've been an AISC member since 1985 and are certified fabricator in Schenectady, New York, which is near Albany. We started our company in 1984 fabricating buildings. Since my partner Jim and I were both professional engineers, we concentrated on small, difficult projects requiring engineering solutions. Many of the projects that we've done are a hybrid of bridges and AESS building work. We have heavy lifting capability, which enables us to fabricate large lock gates and large bridge sections. When Alex Morales of AISC asked if I would be interested in mentoring for this prize, I didn't hesitate to say yes. The projects we've enjoyed most over the years has involved working with an architect and engineer in the design development phase to develop solutions to challenges created by the architect's innovative use of steel in a unique structure. I love the creative process, which I believe is fostered by collaboration, and I think the Forge Prize is a great way to foster both collaboration and creativity. I don't want to take too much time away from Matt, Rosanna, and Hunter, so I've only a few slides showing some of the projects which we were involved with the design and which influenced our collaboration on the Forge Prize. In both Forge Prize presentations, you will see built-up shapes that presented fabrication challenges. With Matt and Rosanna, we discussed bending versus welding versus bolting on the main support structure. With Hunter, we discussed how we were going to field connect and field bolting or field welding the manufactured shapes. In this 151st deep project shown here, we used field bolted end plates to line box sections which were shop fabricated and field welded. Even though the two Forge Prize bridges were very different, the built-up boxes influenced details on both pedestrian bridges. All of the designers involved in these prizes were eager to learn from our experience, and you will see that collaboration in their design. One of the challenges of Matt and Rosanna's design was controlling the shape, particularly if we connected members with welded joints. We shared lessons learned on the Kennedy Center for the Performing Arts pedestrian bridge, which influenced the design to control weld distortion and maintain geometry. The connection method used on this project was also applicable to Hunter's design, which required field connection of different geometric shapes. It was interesting to collaborate on the details, even though it was a competition and not an actual project. We tried to solve problems as if they were going to be built. The Kennedy Center for the Performing Arts project also illustrates what can be accomplished by early involvement of the fabricator, engineer, and architect. Working collaboratively, we assisted in the design and detailed development of this project, similar to the way the Forge Prize developed. The use of weathering steel on Matt and Rosanna's design presented some challenges for human contact. They knew that from the start, and you'll see that they created some interesting solutions. This project, the Tea House, is one of our most enjoyable and memorable projects. It was a collaboration with the architects Simon Ungers and Thomas Kinslow. I also believe this project is relevant to Hunter's in that it showed how the collaboration between an architect, engineer, and contractor working together from concept to completion can create a piece of art. A model of the Tea House is part of the collection at the Museum of Modern Art in New York City. I think this teamwork which existed on these projects that I've shown embodies the spirit of collaboration championed by the Forge Prize. Say congratulations to Matt, Rosanna, Hunter. I want to thank AISC for supporting this prize, and I want to thank Alex Morales for his work bringing us together. And now I'll turn it over to Matt and Rosanna.
We went through this journey about a year ago, so we're kind of regurgitating some memories here, so bear with us and hope you enjoy. We're working here we started a project that was based on a need for an extension of the High Line to connect with Moynihan Station. There were, at the time, multiple entities and interests in this connection, and there's also, as you can see in the site plan, a bus station below, so it made sense to us. We took part in a study and So you'll see our results of that study, and then we went through 2 rounds with the Forge Prize. So there was a first round, and then we subsequently went through a second round where we got to elaborate on our design of this. So just to start us off, we ventured into this zone of weathering steel for multiple reasons, but also because of the lifespan and the sort of interest in the change over time, and just to introduce a element that would not be too closely resembling to the Highline, but might have its own life and kind of mark where its life began by being able to sort of mark backwards from when the steel began its life on the site. So we, of course, talked through some challenges with Glenn and had some prior experiences with other projects with weathering steel and its effects in both a positive, architecturally, aesthetically pleasing way, but also just the challenges that come along with the mixtures of alloys and such, and the finishing, drainage, and kind of erosion scenarios, which create, the need for secondary finishing, which we're hoping to avoid. So a lot of our project has to do with that approach of sort of creating opportunities to not encounter problems. So there's some projects in New York City, which Glenn showed upstate, which is a beautiful project and was an inspiration for us, as well as other cladding possibilities like the Barclay Center and various other projects within the city. So it served as like a sort of path road to using this material expression within the city. Just in a fair disclosure, both Rosanna and I worked on the shed in Hudson Yards extensively, and so we had a pretty extensive experience working on the shed, getting that thing to move, working with Thornton Tomasetti, who also helped us out a little bit on this job, and so I took some of the lessons we learned there, where you can see here between sort of fresh off the grinder steel on the right and the more weathered steel on the left is just untreated steel. It's not Corten, but we took some lessons and sort of found some beauty in the unpainted moments. And since this project is exposed to the outside, we took advantage of trying to pose that challenge to ourselves to keep it exposed.
Right, and we were also very inspired by this idea that what you see is performing both structurally and is ultimately the aesthetic character of the structure, and that was a big part of our project.
So, we spent a good amount of time, this was a fabricator overseas, but spent a good amount of time laboring over details and finding unique solutions for the shed, and took some inspiration from other architects like Calatrava in terms of our structural balancing. We endeavored to create kind of large cantilevers that we're showing here, and you can see in the future project that we took some of these detailing moments and sort of sketched them out with Glenn, sketched them out with our engineer, and came to some interesting solutions maybe that also had to do a lot with using exposed steel, untreated weathering steel. So a lot of these details you might not necessarily replicate through a stainless steel or painted process, but for us were pretty important to maintain just the overall expression, not creating closed voids, avoiding ponding, all those things that cause unique moments of erosion that make weathering steel not so ideal. So here's the plan of our project. Again, like you'd have to cross over, I think that's 9th Avenue, yeah. And to get to this bridge would connect to the spur of the Highline, which was just recently opened when we did this project. And then, so this creates a, both stair and elevator ADA solution, and elevates a park that parallels 9th Avenue, as well as creating a shelter for the bus stop below, potential maybe, coffee shop or retail.
Yeah, so it was pretty critical to us that this elevated park create a public space underneath, and we really took a stance at 9th Avenue that this public space below starts to branch out through Ninth Avenue and kind of reducing the number of traffic lanes, but creating a moment for both commuters to pass through quickly, but then have a moment of pause underneath. And so we'll kind of dive into more details on these planters, but it's really looking at using steel in two very, very different ways. The first, in the primary structure, utilizing the strength of steel in its long direction, but then also toying with the idea of hammered steel and creating a kind of catenary draping effect. And so those two things creating almost opposite geometries, the sharpness versus the voluptuousness. And so I think this section was one of our initial sketches, and we kind of really jumped off from there. And again, that center moment being both like a very primary urban moment that draws people up and is also the main touchdown point. So this section, the long section, is really talking about this idea that we are using these, what we called structural ladders, but essentially we wanted to create the largest shippable components that we can in order to minimize the on-site connections, so that it could be primarily shop fabricated and then brought in and very quickly assembled. And the whole goal, or the framework of this competition, the idea that it is about reducing construction and erection time, we wanted to make that evident in the physical form of the thing. So you're seeing these large cantilevers, which are dramatic from a public space point of view, but it's also really about that kit of parts that comes in and quickly gets attached.
And the view.
And the view, yeah. So this is a view from 9th Avenue, looking for as if you're leaving Moynihan Station, going towards the High Line. So those images were all sort of from the phase 1 of the competition, and then moving into phase 2, where we got involved with SDS Steel and further developments with Thornton Tomasetti.
Right. So the part of the goal is to create a very minimal touchdown. So a maximum public space for green as possible, but park-like and connecting to the High Line with some of the same motifs, but also a very minimal touchdown, as there's subways underneath here and there's various complexities to building in the city, of course. So if we could centralize our foundation and we could centralize on the lower part the elevator and really have those be our primary touchdowns, what could we do to create the most elaborate system of public space up above? So we approached it as though there was like a ladder system that was welded together, bolted together on site. So this would be pieces that would come truckable if we could get them over the bridges and stuff with the weights. And so we'd have this first phase come in, bolt up, and have the second phase with these ladders, which we'll get into more detail later, come together and be bolted up. This is, I think, 6 ladders here. And then we'd create a tension system in the middle, which would bridge these two sides, kind of focus our loads down to the foundations and complete the cantilever. And then after that phase was done, then you could come drop in the planters and let the trees grow, get the guardrails in, and have a relatively quick erection time on this kind of complicated site. So this video will play.
If you click the next arrow.
The next arrow. Okay. So one of the tools that we like to use as a firm is Digital Project. We can get a lot of control out of the geometry this way. So we went through a process of really kind of controlling the geometry in a very precise way for the second round. We rebuilt our kind of sort of scheme that didn't have all the thicknesses and elements involved, and tried to pay attention to all these units. Here's the pin system that would come together after the ladders are installed. It's a fun idea. Yeah, I'm not sure exactly the dimensions, of course, but we're always pushing for the most minimal. But there's a tension rod system underneath, and then as we develop this, it would be a relatively uniform section through steel that would start to array itself.
Right. And a kind of recurring theme on this project is this idea that the visual moment that you would think is doing most of the work here, the center of the piece that's cantilevering out of the ground, is in fact we try to drill down into how it's exactly performing and how the forces are flowing, and then try to create space in areas where it's actually doesn't need to be bulky. So that occurs both in the center portion here, where we've discovered that it's actually in tension. So we try to create these plates that are in tension and really just pinpoint exactly where those forces are flowing to maximize the way we're using steel and the way that it performs structurally. And so that is also goes into the beams themselves. In the first phase of the competition, we were playing with this idea of taking a structural plate steel and in fact cutting it and bending it to create these sort of V-shaped beams, and we're pretty excited about that as both an aesthetic but also as a performative piece. And then as we sort of got into the second phase and really kind of drilled down what that means to both fabricate but actually how it's performing structurally, and we started to see some of the challenges of the nature of the thickness that's required, the thickness of the plate required structurally, but then the need to bend that and some of the deformations that occur. So we challenged ourselves, rather than doing what is sketched, say, on the left in this slide, which essentially stops the structural steel at a certain point and then creates a kind of sacrificial aesthetic nosing cone, let's say. We tried to challenge ourselves and work with Glenn and others to try to go away from it being purely an aesthetic thing, but actually being true to what's happening. So, this would be another version where we could have easily sort of welded on a round piece here and kind of created out all these parts. But we kind of went back to the drawing board and thought about, these ladders, in fact, are at the bottom are wanting to pull apart from each other rather than compress. So we got into these ideas about creating kind of custom fasteners that could clip the bottom of the beams together. And so again, the bottom of the beam that you would see, which is performing a specific way, we actually want to express the fact that there's a gap there instead of something like a rod or something that is continuous.
And also just to allow the weathering steel to breathe. So, keeping the moisture unlocked and having an open section.
So the section on the right is where we kind of wound up in the final design, and we're sort of limiting the welding to the top plates and allowing that, the shop weld locations, and then they're bolted together along the length. So again, those are those sort of fastener clips that we developed through this collaboration. And then the notion that these long elements are bolted together with concealed openings for bolting connections this is just sort of from lessons learned and creates stiffeners within the sections themselves.
And access panels at the top, so right. We could maintain a very tight connection below, but sort of hide these access panels in the future. So the stairs, also kind of a drawing showing the stair along with the tension rods from one side. They kind of mirror themselves as well, showing the foundations and the way it gets built up. So we talked at a good amount with the engineer, with Glenn, just about like where we want to put the bolts, where we want to put the slices, where you could truck it, where the weights become rational, where the cantilevers become relatively rational, and just creating a rhythm here. So the puzzle kind of came together pretty nicely with the geometry, and then we started thinking about like how we do these planters. So what could this planter be? What could the park feel result as? How much true soil and soil depth and drainage do we need? How do we get the sort of drainage out of the bottom of these guys? How do you make the shape and let it be exposed out of stainless steel? So And then there's also various connections which get you down the sort of faster part of the project down to the high line, which is a very light touch of a couple of bent plates. So we were able to kind of bring back our bent plates in this area that ventured beyond the sort of elevated park and bus shelter down to the spur of the High Line. So we wanted to contradict all this kind of nice material and then maybe have some more human interaction that wasn't total machinery. Take a piece of steel and just hammer it onto a form to create our planters. So this would actually could be done in multiple ways, and we had various conversations with Glenn about, this is really kind of the best way to maybe piece it together in 4 parts and weld it up. Maybe there's some wire mesh, maybe there's a way to kind of cast or do something more unique. And so we went through a series of conversations and found that maybe if we did like a mold and used a couple cross wire meshes and then took a relatively thin expression of steel and stainless steel, and we just kind of mashed all these together in a frame, could you do that and allow the drainage through and still get the expression we wanted? So we were able to figure that out. And then, consistently we're asking ourselves this question, as well as we did through other projects that were done in steel, big and small. And for us, the duration of the competition, it was a beautiful thing to have Glenn for the second phase. We could have used him in the first phase. So I think that there's no best time. As soon as you have a good idea, I think it's great to bring some people to the table. And of course, then, there's the erection scenario, which I think also, SCS had some expertise in, but also gone through this process of building large components in the city and thought about it as a puzzle of parts. We even got so far as to designing these clips and, access to them and replacement of the planters. And
right. And that was the kind of like the idea that these large components are shipped into the site and are not only their connections are prefabricated, but they're even the sub-elements that you would think would then come in and be secondary or another trade, that logic is also baked into those sections all the way down to the sort of the minutia of pieces that are going to attach onto that element. And so that it's all kind of thoroughly coordinated and thought through even before it arrives to the site.
So we got enough time to think about, through the second phase, think about how drainage would happen, how we would get this water not just pumped right back into the sewer, but kind of filtered through the site and what would happen at the ground plane and not having a whole system of irrigation tubes. So they're allowing the water that would be collected within each planter to filter down, pass through sort of a drainage drip scenario through, because, with weathering steel, there is a slight concern about just the runoff having enough of a rust color that it might, which we might love, a rust color just spreading its way down Ninth Avenue. But, we sort of took the challenge on to do something maybe a little bit more unique and just kind of created a light source and planter for uplighting, and then also just a little bench to kind of sit and take a phone call. So we got into some of these little details.
Right, and it kind of took the project beyond the sort of the sculptural elevated thing down into really feeling like a piece of Manhattan and starting to create in a way its own urban infrastructure where it is both a lighting element, a seating element, but something that's kind of iconic that ties the elevated element down to the ground plane where people actually interact and have kind of more tactile experience with the bridge.
Yeah, so we basically saw this sort of puzzle coming together with this scenario. It's a relatively complicated drawing Rosanna did here, but pulled all of these pieces together in like a clearly delineated way, which focused, of course, with the competition on steel, but also on constructability and sort of rhythm of execution that was inherent to both, the High Line in its origin, and also just, the kind of references to the city and the city grid and the urban environment of this part of Manhattan. Of course, this is doesn't have a title; it's just the railings. And then we got in, as we would get into all the railings, the benches that might surround, using a sort of expand mesh.
Right. We started out with a glass rail in the initial phase, and then kind of quickly realized we wanted that railing to dematerialize and not be so reflective, and to be more in the same vein as the weathering portion. So we kind of shifted to a mesh condition, but always working with the V-beams as the geometric logic, and then tracking those angles all the way through.
And the beauty of the rust at night, the way it might add like a nice softness to the otherwise cool environment, and then the sort of lighting scheme as you got up above, and then really creating kind of an environment for pausing within the city, having a little bit of shelter. And
this image, this was really exciting for us to visualize and finally see the project come to life, because this was really what we were after, was the same material, the steel, but being presented in two very distinct ways, structurally, visually, all. So this kind of where it tied together all of those aspects, and is we would assume, a very fast thing to construct, and that was really kind of the goal here.
Yeah, and I think, to summarize, we just really are grateful to the AIC and grateful to the Forge Prize, and we had a wonderful time doing it. We'd love to build this tomorrow, as probably Glenn would as well. So, but I think that it created a really kind of unique moment for us to explore a little bit as architects, and have some conversations with a fabricator locally that felt like a real project, as we did a little escape from, the normal years-long routine of a project, and really kind of compress it for quick decision-making, and really being creative as a group as we discuss the project. So we want to kind of summarize here, and of course look at this year's winner, which we'd love to hear, and take any questions.
Thank you, Rosanna and Matthew. We do indeed have a question. We wanted to know what software was used for your 3D model, and was this transferred to STS Steel for their use?
So, we, full disclosure, have been doing some pretty complicated projects in our work life. So I was using CATIA. We do some of this early kind of form finding in a mixture of Rhino and 3D Max with, rendering software. I think that the one beautiful thing that we found was that, not to get too deep into the software question, but there's a lot of kind of push to Rhino. The thing that we found in dealing with fabricators using CATIA for facade systems, as well as structural systems. I mean, the shed had, I don't know how many thousands of moving parts within moving parts that all had unique tolerances. Geometric control was a real sort of embedded part of our process to this point. So we can really define geometry in a very, very precise way through a relatively mathematical set of equations and relationships through CATIA, and through doing that, able to just provide any sort of file format or any angle or any drawing or 3D model to almost every software. So not just center lines, but if you want to do any sort of analysis, it feeds and exports in a very precise way to almost any pieces of structural or fabricator software, CNC machines, etc.
Okay, thank you. That's all the time. But there's another question coming in. Let's see, I can do this. How may you envision the bridge's flexibility to incorporate an additional structure, for example, a coffee shop or a retail node?
That's a good question. I think for this project, we were mostly interested in moving large amounts of people, particularly this issue with commuters, right? The Highline, as we all know, gets very, very crowded, primarily with tourists moving through. And so we were challenged with how do we create a fast path versus like a slow path. And so even the form of the bridge that cantilevers as being something that you can linger and sort of hang out on the greenery versus the diagonal that slices up from the street up through and expresses right across to the Hudson Yards. So programmatically, it was mostly about circulation, but certainly with the ADA component of the elevator and the space underneath, absolutely you could imagine a moment of cafe or something happening under there. But I think like any more kind of infrastructural-based project, this kind of thinking is really about what it is in context next to. So for instance, if you're all seeing the plan on the screen, you know, the bridge is right next to an adjacent building that has a ground floor that is essentially creating a covered awning over that space. So we didn't integrate programs, but as an idea, systematic approach, you could imagine, you could imagine other buildings spilling out underneath and around this space.
Yeah, you know, New York lives, like it has adaptability, and so I think that, you know, part of our interest in the High Line and working around the High Line as we have in our other professional lives is that there's all these unique opportunities that get filled in, right? There's now art galleries, there's performance spaces underneath the High Line, there's, you know, all these other buildings that are engaging with it. So as New York kind of lives on and breathes on, we would certainly envision this bridge as part of the life of the city that would get adapted and added onto or subtracted from, or, you know, you could imagine taking away some of these planters and kind of poking through some skylights as we did here and there,
or create sandboxes or different areas.
So it was kind of like just a bit of a prototype type of project, but for round two we focused predominantly on the steel because that was the nature of the competition, not necessarily on program. But we'd love to build it and focus on program, of course.
Awesome. And then I have one final question. Is the presented model an FE analysis?
We did get very minor, just centerline structural analysis from TT. I mean, with Glenn, we were mostly talking about details because, you know, within the range that we're operating, there's a relative confidence based on just basic sizing from our structural engineer from TT. But generally, that was our extent of analysis.
Awesome. Thank you.
Thank you, everybody.
Thank you so much. With that, we're going to hand it off to Hunter and the 2021 Forge Prize winner, and we're very excited to see this project ourselves. Thank you.
Awesome. Thank you. First off, just congratulations to Matt and Rosanna. That's a fantastic project and a hell of a thing to have to follow right now. So congratulations again. It seems we're establishing a bit of a pattern with Footbridges winning the Forge Prize. And so it's my distinct honor to present it to everyone. So I am Hunter Ruthroff. I'm a bridge designer with TY Lin International based out of San Diego. You all know Glenn, who is my mentor and a pivotal part of the design. So here we go. So as I said, this project is focused on a footbridge in Florida Canyon. To give you some context, Florida Canyon is inside of Balboa Park, just north of downtown San Diego. And the footbridge really functions as an extension of the Prado. And the Prado for us is our historic spine. It has many museums, shops, restaurants. It's kind of the beating heart of Balboa Park. And it starts right next to 6th Avenue, which is on the western boundary of the park, crosses over the 163 via the Cabrillo Bridge, which is an important part of this project, and then continues to the Balboa Fountain, which is right next to Park Boulevard. And the idea that it emerges from the west, or as the western entrance from the Rose Garden over the canyon and into the eastern rim of the Arizona landfill. And so the whole idea of extending the Prado over to the east rim of this canyon is to really spur development. That area has been highly neglected over the last century since, the Cabrillo Bridge and the Panama, California Exposition occurred in 1919. And so beyond spurring development within the eastern part of the park, it's also would function as a very needed east-west connection for the neighborhoods of Bankers Hill on kind of the west side of the park, and South Park and North Park on the east side. And so, as I said, the Cabrillo Bridge was a big source of inspiration. It's a fantastic structure. When you're on it as a pedestrian, it's quite open. It gives you views of the ocean and downtown in one direction. If you look down its axis, you can see the Museum of Man and its towers, and really the Prado as it folds into the Plaza de Panama. But it also functions as a gateway in and out of downtown via the 163. Really has a magnificent kind of silhouette, particularly at night, which you can see here. Also, in the bottom left of this image is its construction. And so it was noted at the time that 1 million board feet of redwood was used in the falsework and forming system of this structure. And so this proposal really seeks to kind of find efficiencies in the construction process where we're really trying to minimize the footprint in the canyon ecosystem with either temporary or permanent structures. But we're also looking to really push the boundaries of what's possible in structural steel via 3D printing. And obviously, we want to find a more efficient construction system than how this was originally built with the Cabrillo Bridge. And so there are other sources of inspiration, most notably some of the Prado architecture, specifically kind of this highly decorative ornament that you see in the Spanish colonial structures within the Prado. Really amazing how kind of the light and shadow are kind of flickering off of these surfaces, and something that I really focused on trying to bring in abstractly and kind of modernize for this structure. Fluidity is kind of a permeating theme within the park, most notably with its flora. So we have throughout Balboa Park massive fig trees. They're obviously not endemic, but they are a part of our identity nonetheless. And some of these trees have just fantastic kind of buttressing root systems that are very fluid. There's also a big cactus garden just adjacent to where the west entrance would be. If you kind of like focus in on some of these fluid forms of the cactus and then this dragon tree, which you have these really ornate kind of bifurcations in its trunk system, and even some of the up close texturing that you get, it's just a very rich piece of inspiration to draw from. And lastly, there was obviously inspiration that was drawn from the canyon itself. So on the left, we have an aerial, and it kind of reveals the trail network that exists via pedestrians and mountain bikers. Really kind of looks like a kind of a cellular system. And then on the right, the process of erosion, kind of a zoom in on what the resulting surfaces are from erosion and kind of water trickling down and carving this canyon. And so really what we can think of is the architectural concept is kind of a mashup of these three components. So we're taking kind of the Cabrillo Bridge and kind of looking at its kind of base structural system where it's open above, it's a gateway from below, the structure is kind of tucked below, and that kind of sets the tone for the type and experience that this proposal is trying to seek. And then I made the decision to emulate or kind of mimic that cellular network that we see in the trails as kind of the thing that influences the global architecture and structure. And lastly, the third component is really focused on surface articulation. So taking that Spanish ornate and trying to modernize it, but using really kind of fluid forms as the actual kind of aesthetic to pull off. And so here's kind of a plan view of the project with an elevation below. So we can see on the very left of the screen the eastern reach of the Prado. There would be an at-grade crossing and then a plaza that leads into the west abutment. And the bridge really lays out as kind of 4 expanding and contracting moments where they really function as overlooks, but they are expanding to accommodate these portals in the structure, which allow you to view through the bridge to the canyon ecosystem below. But these apertures also feature something unique, which is hammocks. So the idea of being able to suspend yourself above those portals, just kind of have a wonderful leisure moment while you're kind of looking below and being able to appreciate the spatial articulation of the structure while you're on the deck. There's also vegetation integrated in between these portals, kind of the idea that we want the structure to function as an extension of the Prado, but also an extension of the park itself, so that while you're on it, you're getting wonderful views, to the ocean, downtown, the canyon ecosystem, and its vegetation. The structure is divided into 3 250-foot spans with a 3% slope from east to west. As you can see there, it passes over Zoo Place in the lower left there, and then Florida Drive to the right of the eastern column. There's also many trails, as you can see from the plan view, passing under. They give you really wonderful moments to look up at the structure. So here's our first view of that structure. The whole idea of taking that networked kind of cellular system that we see in the trails and using it to drive the overall architecture of the bridge, I think really kind of matches up with some of those trails when you view it from either rim. I think it's even more noticeable in the dry season when things aren't so lush. You can really see the pathways kind of emerge and then really kind of function as a matchup with this silhouette. So this is a view from Florida Drive looking north. You can note the vegetation over strategic moments where there are spandrels below, and so those are all integrated as planters. And so this is our kind of first view where we get to see that surface articulation close up and personal. So this would be, if you're driving on Florida Canyon, just passing by the eastern column. And what I would point out is kind of the way and manner in which these kind of spherical components have kind of a path that's traced along them. What's happening is I'm using a flow analysis tool, which kind of mimics the process of water or particles in this situation, and tracing them down to their lowest path. It really is as if you poured digital water into the volume and then traced its path on the way down. So I think it is kind of reminiscent of that Spanish architecture, not literally, but really kind of more abstractly. And the effect is such that it looks like it's either, these components are either growing up and emerging from the canyon landscape or even dripping down into it. So here's a few more views of kind of the deck experience. The upper left is as if you were below the soffit looking toward that hammock and kind of portal, in which case there are many kind of involutions to connect, the ground plane with the structure itself. Kind of a view as if you're hanging out on that hammock, being able to see below to the canyon. And then here's a view from above where the two kind of focuses in on how those two paths, which are 10 feet, split around the portal. And then in between the portal and the planters, there's areas for public art, kind of something where monthly an artist can come in or even annually come in and kind of leave their mark and identity on the structure. Another view from below, looking up through the hammock on the upper right here, view on the hammock, just to get an idea of what that experience would be like. And then if you were kind of sitting at the planter looking toward the Prado to the west. And so much like Matt and Rosanna, there was kind of a two-part process in this version of the Forge Prize. The first, my feedback was really to focus on lighting and how that would contribute to the structure, specifically on the deck, but also architecturally. And so you can see here, the lighting system of the deck is kind of tucked into the lower reaches of the barrier so that it looks like a sweeping ribbon of light that connects east and west. And you can begin to see some of those surface articulations, the spherical ones specifically at the ends of the path, glow. And the point is that these are actually luminaires. And the idea is that at night, when you're walking in the trail or biking, which is quite common to Florida Canyon, you can look up and see beyond on like a starry night, these kind of resemble a constellation of sorts where the silhouette really starts to fade away. And that lighting system looks quite chaotic, much like the constellations. So here's a view on the east rim. The upper image is looking southwest. You can see the Coronado Bay Bridge beyond the Naval Hospital. And then below, the east rim looking northwest. And one of the many possible variations of lighting design for this, where there's essentially isolating the lower lights as red, sweeping from the column along the kind of arch member, and then the above section being kind of a yellow light. Obviously, there are many possibilities of programmable LEDs these days. And I think this image really captures that kind of surface articulation and kind of reaches back to that kind of Spanish ornate with the large sweeping kind of paths, and then how those spherical articulations kind of terminate in this moment that you can see between the involution of the arch member up to the soffit below. So here's an animation. And so the next two videos kind of focus in on how this structure was kind of modeled. Just a quick preview. Essentially, I'm using a mesh relaxation technique, which is you plug in fairly rectilinear, normal kind of geometry, and then this mesh relaxation essentially induces tension into the system as if you were kind of digitally pulling fabric. It's really a form bonding process, which leads to that overall smooth articulation. And then the second video focuses on how that kind of path of the kind of surface articulation was traced. So you can think of it of it as even distribution of points across its surface, and then the software is kind of recording those points on a set interval, which allows you to kind of trace those as vertices to its lowest point. And so, as you can imagine, having to take a structure like that through final design is nothing short of a nightmare. Everything is spline geometry and it's very complicated. Having to kind of draw that out and define those as radial arcs, as profiles and alignments is really a tedious task. And of course, we all know steel does not necessarily want to be doubly curved. That is unless you're 3D printing it. And so what we're seeing on the slide right now is the fabrication of MX3D 3D's canal bridge in Amsterdam, and the process of using wire arc additive manufacturing, which the abbreviation is WAM. Essentially, you're sticking a welding rod to the end of a robot arm and tracing sections, and you're basically getting that section at fractions of an inch at a time and building that part up. And so this particular project is about 9 to 10 meters spanning over the canal, and it's all printed from structural stainless steel. And it leads, obviously, has really high potential with fluid forms and creating those out of steel. And so the bridge is not printed all in place all at once. The kind of concept here is to print individual components and then piece them together. And so the components of this bridge are really of a similar size and scale as that Amsterdam bridge. And so what we're seeing here on the screen is a spandrel component being connected to an arch component. And there's kind of a three-dimensional section taken through it, highlighted in orange. And so we're able to see the internal stiffening process, which is designed as a series of kind of diagonal crisscrossing stiffeners. There are many ways to kind of do this, and kind of the idea was we wanted to highlight with 3D printing stainless or just steel in general, it really opens up a world of possibilities from both a formal standpoint, but also I think challenges engineers to think about what would be the right kind of system and not having to stick to planar elements and diaphragms and stiffeners on the inside. And so there's internal stiffeners. The internal stiffeners are an inch wide by 6 inches deep. They are, of course, integral with the outer shell, which is 2 inches. And then at the ends of these components are essentially flanges that are bolted or abutted to one another, and then bolted from the inside so none of the hardware is exposed. And of course, that's done via a porthole which someone can climb into and have access to accomplish that. You can also see some of the surface articulation, which is also integrally printed to the structural section, then also the kind of luminaires that you see here. On the right is kind of a zoom in of this section, and at the time of the first submittal, I was kind of proposing that the whole thing would be printed out of stainless. But of course, stainless is an expensive material. If you can use carbon steel, that's a good direction to take. But of course, with 3D printing, you're able to isolate stainless layers versus carbon layers. So most of this section is carbon steel, and just the outer quarter inch of the entire part is encased in a layer of stainless, which of course helps with maintenance and durability over the long run, especially since we're about a mile from the ocean. And so these components are fabricated in the Arizona landfill. Since it's kind of not a great area at the moment, the thought was that there would be a temporary facility that would be built in that site. And then the advantage of that is that you can print larger components and because you're not reliant upon printing at a factory, getting it on a road, and being confined to, say, the truck bed size. So really your limiting factor is what can the train effectively lift into place. And so this is the slide that we're looking at now is a 3D printed model where I'm demonstrating a balanced cantilever segmental construction technique. So the first image, all the grading civil work is done, foundations and abutments are in place. The smaller eastern pier is put in to kind of bring us up to the same elevation, at which point we place the upper piers. And what we're doing from there is installing temporary stay towers to support the arch components as they're cantilevering out. And so really it's as one component gets brought on, it's attached to a cable to support it until we get to this moment where we put the quote unquote keystone component in. And so at the fourth arc segment, that first keystone goes in. And then finally we get to kind of the fifth arch segment, and then finally the outer keystones. And at this moment, what we have is arch stability, where we can then take away the stay towers and build from the arch up. And so the next sequence would be placing the spandrels. And then after that, the first segment, deck segments, and then the final deck segments, which are seated in between the others. And so there's a lot of advantages that come with 3D printing in general. That whole notion of file to factory is very efficient. Again, we're bypassing having to draw hundreds of pages worth of splines and point cloud and that kind of defining moment. We're also, I think, simplifying kind of engineering, but enhancing architecture in the sense that we're really, as architects, getting formal control back. You know, it's not limitless, but it really, I think, will bring in an era where we will start to see heavy articulation of surfaces and complex components. And when I say simplifies the engineering, I really mean in kind of, if we were to compare this to, say, concrete 3D printing, the way that we've kind of seen this being done is you kind of print the concrete components, and it's got kind of a cavity that then you really need to figure out tendons and reinforcement. And so while that is a step in the right direction, that is a serious kind of challenge for us to figure out. And because of steel's ductility and tensile strength, I think it kind of brings it back to a moment where we're kind of in school and we're thinking about that section as post-shade space. And so that's kind of what I mean by the simplification. The other thing I learned is for steel 3D printing in particular, fabrication really, speed is a function of robot count. So it is not a quick process. If you're trying to build this project with one robot, it's going to take you a long time. But the ability to gang up robots on a particular component where they can each take different areas of the section really would speed up the fabrication process. And as, like I said, the temporary on-site facility reduces the number of components and really increases the construction speed, leading to a better project. And so with that, I'll hand you off to Glenn.
Okay, well, thank you. That was great. Thanks to both. I'm not planning to go through these as we already went through them before, but just want to say that I was very impressed with all the people who competed on this prize, and it was a pleasure working with Matt, Rosanna, and with Hunter. I enjoyed getting to know all of them and how their experiences inspired their design. Particularly with Hunter, this year I was not that familiar with 3D printing, particularly at this scale, but the more I worked with him and understood the technology, the more enthusiastic I became about it. And I think one thing that this Forge Prize shows is that architects' creativity, it drives engineers and fabricators to find innovative solutions, and it pushes our industry forward. And congratulations to all the winners, and really appreciate the involvement with this with this prize. Thank you.
And so with that, I'd like to open it up to Q&A. Thank you.
Thank you. We do indeed have some questions from the audience, but before we do that, I would like to do a couple of the interactive polling questions. So, okay. So everyone should be seeing the first poll question. And that question is, true or false, emerging professionals in the design industry have no role in leading practice trends and objectives. So please participate by clicking the answer you believe is correct. And I'll give it a few minutes. Okay, so 83.3% believe that this statement is false. And Hunter, Rosanna, or Matthew, do you want to speak really quickly to this question?
This is Matt here. I think, I'm super interested in like Hunter's process and the way that we can push things forward. So even though our particular project might feel like dissimilar in some ways, but I feel like there's a push going on with both of these projects to engage moments that are somewhat overlooked from an architectural point of view. And so I feel like the poll results are great.
Yeah.
I think some of us young people may see things differently, or younger people. So I think that, it's a beautiful thing to have a forum.
Agreed.
Yeah, and I'd just add to that, I think it's really kind of the opposite. I think that young blood being pumped into the industry is really what drives trends and objectives, of course, with collaboration of your experienced colleagues. Just as an example, when I first joined CY Lin, we were using Rhino, but we weren't using Grasshopper or any interoperable tools. And the introduction of this via, education and just, personal research has really increased our workflow and made us efficient. And obviously, we're pushing formal boundaries too.
Awesome. Thank you. And then the next poll question is, what is the purpose of the Forge Prize? Is it A, to determine how hot steel is, B, support emerging architects by opening the resources of structural steel industry for inspirational and iconic design through industry mentorship and design collaboration, or C, build things without using materials? And I'll give people a few seconds to answer. I think it's pretty obvious that the 100%, that's great, that the answer was B, to support emerging architects by opening up the resources of structural steel industry. Do any of you want to speak to this question?
I would just add that I think it's a great competition, and it's unique in that it is bringing in fabricators and bringing in reality and gravity and joints and all those kinds of things. Bringing in those questions to a design competition is really fantastic, and we see a lot of competitions out there, and we enter some of them, and quite often the things that win, we're always very surprised that, sure, there's a vision, there's a pretty picture, but our interest as an architect and as in projects we've done in the past, how do you get it from that pretty image to the reality? And so I think the Forge Prize is really a unique opportunity for young designers in that way.
Agreed. Awesome. Well, I do have some questions for Hunter. Hunter, what software was used for your 3D model, and can the data be exported for use by the Fabricator?
Yeah, so it was definitely a heavy Rhino Grasshopper focused project with a lot of different third-party plugins for the flow analysis. Kangaroo was used for the mesh relaxation, Dendro, and a few other random plugins. But yes, there are, I mean, if it were to be connected downstream to, say, Sophistic or SAP or any of those other programs, which are all very possible, that gets you into the analysis realm and structural engineering. The leap from there to fabrication software kind of eludes me a little bit more. But specifically with this project, the idea is that the shop drawing becomes really the design file at the end. So being able to hand that Rhino file over to MX3D is all they need to start printing. So it's a very efficient process.
Very cool. What structural and material specifications would be used for the real bridge?
That's a great question. I would leave that to my colleagues at TY Lin, as they are far more educated in that matter. I would just add that through this process, there was lots of collaboration with my colleagues at TY Lin, MX3D, who's the Touch 3D printer, and then obviously Glenn. And so it was a very harmonious process.
All right. And then is anyone concerned about long-term residual bleed of Corten steel on other portions of structure or foundation or surfaces below?
Well, this is encased in stainless, so there wouldn't be that kind of bleeding, to my knowledge. Maybe that was a question for Matt and Rosanna for their project.
Possibly. Matt?
Yeah, we talked about that pretty extensively with Glenn. We've also talked about it, with other people, and I think that both there's precedents out in the world. I think people get nervous about that, but the reality is, the runoff from any given car is far worse than this bridge over time, and I think both to like plants and animals, but also to the earth as well, but also staining wise. So I think that if you look at anything individually, there's a concern, but I think there's ways to mitigate it, and we tried to control it in some ways, but I do feel like part of life has to do with getting a little dirty. So I think that it's a little bit of an interest of ours to sort of, maybe take a little piece of the bridge with you if you were walking by.
And then also, as part of that, like you mentioned, to design into it intelligence about drip lines and really drilling into the detailing of the angles that surfaces are and where they're sloping to and where it releases back to. And so that was absolutely part of our thinking with the underside and how the drip lines integrate with the sidewalk below, and that anything you actually physically touch is in fact stainless, like handrails and those sorts of things. So I think it's definitely a part of it being a natural material, naturally protected material, but that the geometries are created in such a way that minimizes direct brushing up against it in an extreme way.
Yeah, Glenn could maybe even talk to this a little bit, but the actual way that the Corten, the weathering steel, works is that rust kind of tops out after a distance. As long as you avoid any ponding and you avoid standing water on it, there's an actual kind of scientific oxidation and sort of rusting process that sort of caps out after a distance and sort of self-seals and protects. You got to go a little bit thicker with the steel, anticipating that level of kind of porosity coming into the surfaces. But over time, it kind of descends in its arc in terms of rusting, and it just becomes a self-encasing finish. I mean, Glenn was showing us pictures of that tea house over time, and it was just beautiful. Like, there's a pathway that people walked on consistently on top of the steel, and it just looked beautiful. Like there was like a pathway in the park, right? Like in the grass or something. It was really kind of amazing.
Cool. And then lastly, how is the quality control done on a 3D printed steel component?
Yeah, that's a great question. Really, it's so there are efficiencies in the process of designing and taking a structure like this through final design. But one of the major increases of a process like this is that quality control really jumps up because the risk is now placed on the designer and the structural engineers. Everyone has their own process of quality control. TY lenses is quite rigorous, and so really it's more about switching your mindset from reviewing plan sets and really becoming computational and 3D in the way that you view this. So software like InfraWorks or just being great at Rhino and being able to kind of get in and out of those components and having a keen eye is very important to that process.
All right, thank you. All right, that is all the time that we have for today's question.